Hey everyone, we're going to go ahead and start the 1.4 section today, but before we do it, let's do a little warm up. So now would be a good time to just simply hit pause, try and work through this for a little bit, and then hit play to hear the description of it. Just so you're aware, this is a solid dot, meaning this line ends here, and it's not super clear, but this is an arrow down below, so the line continues going down. And this is a harder one than you might think, so hit pause. Okay, so now we're going to hopefully hit play and do it real quick. It says determine whether this is a function, and what's the domain and range, and do it in both set and interval notations. Now this one's actually a little tricky. So let's look at it. First of all, is it a function? If I was to draw a vertical line through all parts of this, would it connect with this more than once? And the answer is no. So this is a function. Just so you're aware, this is a line. You guys studied these all the way back in 8th grade math and really heavily in Algebra 1. So a line is always a function. Isn't that wonderful? Except in one case, when it's straight up and down. So there we go. That's not too bad. Domain, oh look, it's got a dot here and it goes infinite. Now this is really actually kind of hard for some people. Looks like it's on the -4 line and it's pointed down, and some people go, oh, that's negative infinity. We're looking at this side to side. -4 is the lowest it goes here, and notice it's a solid dot, not open dot, so it hits -4. And while it is going down, it's also going out infinitely up on the x-axis. So that goes up to infinity. Ooh, that one was hard. So in terms of writing this, I would say it goes from -4. It hits it, x up to infinity. So set notation, all I'm going to do is throw an x, a bar here, and put our braces in. Done. If you had left it as like x is greater than or equal to -4, that's fine too. It's just harder to write that in interval notation. Then looking at my range, this one's hard also. And this one's a trick on purpose. What is my range? So the highest it goes, and it hits it, is 5. That's that 5 line. Okay. The lowest it goes is, oh, hey, it doesn't go to anything, like it doesn't stop. I mean, it just keeps going. So it's going to go down, -5, -6, negative infinity. Now you have a real tendency, and it's drawn this way on purpose, to want to go, oh, look, it goes from 5 to negative infinity. And I go, oh, that's too bad. It is low to high. So what's the lowest number for the range? Negative infinity. And that might have got some of you. It's y, because we're talking about range, and it goes up to a height of 5, and it hits it. If we're going to do the set notation, we got y and the bar, and then our braces. Not too bad. So there you go, there's set notation. That really hits people. Oftentimes, you might have reversed these two, and that's okay if you did. We're still learning and practicing, and I drew it on purpose like this to make it complicated for you, so sorry. Okay, interval notation. We're going to just take these two numbers, -4 and infinity. It's hitting the -4, so I need a bracket. It's not hitting the infinity, so parenthesis. And this is x's and e's. Second one is a y and an e. We've got negative infinity and 5. And there we go, all done. So that's the basics. Hopefully you're still doing pretty well on that. Now here's 1.4 for the day, and we're going to try and do all of it very quickly because this is all Algebra 1. Mostly, this isn't too heavily on the IB exam, but you use it so much throughout the year. It's important you just know how to do it. Now this is all linear. So rates of change and point slope form, slope intercept form, all that fun stuff. So this hopefully is the nice easy unit for you and where you really succeed. Slope intercept form, I'd recommend you write down the words and then write down the actual equation. If you don't know what m and b are, write down what they are. Slope is m, y-intercept is b. Linear functions, oh wow, look, it's the exact same. So they're just simply saying that it's linear and it's a function. That's all this is saying. It's nothing new or different. All right, y equals mx plus b, that's slope intercept. This says find the equation of the line that is parallel to this and through the point -3, -5. So unfortunately for you, it's not in slope-intercept form. And why is that important? Well, it's important because we need to know what the slope is to find a parallel equation. And this you probably worked on, but it's been a long time. This is what we call standard form, by the way. The x and the y are both whole numbers and on the same side. So we're going to start by just solving this equation and moving things around until I get it how I want it. So those cancel. I have a 9y equals 27 minus 6x. I'm going to go ahead and divide everything by 9. So y equals, and I'm going to probably reduce as I'm going if I can. This is 3, and this, even though it's, fine, let's say you're not good with fractions, you don't know that's 2/3. Let me show you in the calculator real quick. I can type in my 6/9. Might want to hit enter, doesn't really matter. And if you're still not cluing in, you can hit the math button and then the top one for frac, and it will turn it in the lowest possible fraction for you. And that's really a handy tool. Don't be afraid to use that. So here's my equation. What's my slope? Negative 2/3. Please don't tell me it's 2/3. It's negative 2/3. And please don't tell me it's negative 2/3 x. It's not. It's just negative 2/3. Parallel means the new equation has to have the same slope. So far with the new equation, I know it's negative 2/3 times x plus some number. I don't know what that number is. That's kind of the whole goal, is to figure it out. They told us it needs to go through -3 and 5, and those are coordinates. It's an x and a y. So I'm going to write a plus b as a placeholder. I'm going to plug in those numbers. -5 equals negative 2/3 times -3 plus b. Hey, look at this. The 3's cancel. Hey, look, the negative times a negative. It's a positive. It's just 2. So -5 equals 2 plus b. And when I finish subtracting, I've got -7 equals b. So that's my kind of final piece that I needed. So the last thing says find the equation. So you need to actually finish by writing the equation. Y equals negative 2/3 x minus 7. Done. Okay. You're going to start to see yo-yo a lot. I really don't like yo-yo, but one of the previous teachers loved it. So yo-yo is like a yo-yo. You start with it at you, you throw it down for your trick, so it's like away from you, you pull it back up, it's at you. So it's like me do one, you do one, that kind of crap. So that's what that means. So you're welcome to pause it and attempt to try this. It's just simply saying that previous problem, the one we just did, now try one that's perpendicular. So you should remember, we just did it. You can see what our equation was when we moved it around, okay? So what would be a perpendicular slope to this? We'll flip it over and make it opposite, so 3/2. Okay? So y equals 3/2 x, and we don't know what that y-intercept is. It's kind of the whole point of what we're trying to find. So we need to go ahead and plug in our x and y's. And we can go ahead and reduce and solve for this one. That's hopefully not too terrible. So multiplying this, I've got -9/2 plus the b, and then when I add that over to the other side, I get -1/2 equals the b. Now you guys are kind of at such a level that all this crap writing it out isn't super necessary. It's okay to start kind of skipping forward, but you do need to have some work of some sort. So my final equation is y equals 3/2 x minus the 1/2. Now the second part of this says, how do we find the x and y intercepts of the equation? Now, you should be able to see one of the intercepts, that's the y. But let's say you don't really get that for whatever reason. You can actually use standard form to find it pretty quickly. I can solve it in two different ways. I can say, well, what happens when I plug in 0 for the y? So y equals 0. And when I plug it in, it kind of cancels this piece out. And I can solve, what is 6x equal to 27? So you just go ahead and divide the 27 by 6, and x equals 4.5. So when y is 0, x is 4.5. It's not terrible. You can do it the same way, but the other way. So when you plug in x equals 0 into the standard form equation, that piece kind of goes away. And solve for the y. 9y equals 27, and when you divide each by 9, y equals, my brain, it's all, not working quite too well, is equal 9. So, wait, that's not right. Equals 3. Jesus, you can tell I'm struggling tonight. So there we go. And then we look at this and we go, well, shouldn't it be this? And we go, oh, okay, wait a second. Were we finding the x and y intercepts of this or this? Remember, these are two different equations. This is the perpendicular one for this. So it doesn't really matter. It's a poorly worded question. Pick whichever one you want to deal with. But in terms of this equation, these are the two intercepts. This would be the y-intercept of your new function. How could you go through and then find the x-intercept? Well, you can simply plug in 0 here for y and solve on that aspect. So it's not super difficult, but these are the things that you should have learned in Algebra 1 and should hopefully have been reinforced in Algebra 2. Crash course today. All right, moving away from that, we're going to talk about point-slope form for a few minutes. Point-slope form, this is what I'd write down, point-slope form. And then here is the equation for point-slope form. The ones that you fill in are the y1, the m, that's slope, and the x1. It's literally like it sounds. You get a point and you get a slope. So this says find the equation of the line in point-slope form and then graph it. So graphing, I'm not too worried about. At this point, you should know how to do that. You have a graphing calculator. It tells you the m, the slope, and it tells you a point. So all you have to do is plug these pieces in the right spots. Be careful. This is x and this is y. Don't just get, lazy and take the 2 and plug it in here because it's first. That's not how it works. So I'm going to write y minus my y1. Oh, wait, look, that's that second number. So -5. It equals my slope and a parenthesis, x minus the x1, which is 2. Now, we don't have a whole lot to do to clean it up. We just got to make sure that those become plus and you're done. You don't want to take the 5 and move it over. You don't want to distribute the 2 in. You want to just leave it. This is point-slope form. Now, some of you are like, well, I should plug in numbers for x and y. No. It's an equation. Equations have to have equals, x's, and y's for the most part. There's always some variations of the letters, but there you go. You got to have your letters. You got to have the equals sign. So that's all we do for point-slope. In terms of graphing it, it's different to graph point-slope than slope-intercept. You just simply graph your point, so 2, -5. Put a big fat point there. And then you literally just count your slope from the point. This means up to right 1, up to right 1, up to right 1. And if I had a nice pretty ruler, I would connect it and put my arrows. Not too bad. Did I need to know where my y-intercept was on this one? No, I didn't. It's a different way to graph the same thing. And then finally we have linear equations. Now notice I'm going through this really pretty fast. So you're going to encounter quite a bit of word problems this year because it's really about how to apply and understand what's occurring. It's not about just how to process this. Speed of sound, so part B is actually just calculate it. Determine the speed of sound at a temperature of 20 degrees Celsius. So where do you plug in the temperature? Right there. And I'm sure you all have a calculator. So part B, plug it in. You got 343. Part C says if the speed of the sound is measured at 361 meters a second, what's the temperature? So again, you're plugging in, but this time for V and solving. I hope you're able to do that sufficiently. So in this one, your temperature is going to end up equaling, I think, 50 degrees if I did it right. Okay, and I want to loop back around to that A again, interpret the meaning of the slope. And so looking at this, our slope and y-intercept. The y-intercept's not too terrible. If we were to plug in 0 for your temperature, obviously that zeroes this out, and your velocity is 331. So velocity is 331, y-intercept is 331. In terms of slope, it says interpret the meaning of the slope. Well, we have 3/5, so that means it's going up 3 on your x-axis and up, or over 3 and up 5. So it's a 3/5 up kind of deal for slope. And we're talking about temperature and velocity, so that you're not going to be going up individually like that. But overall, slope's 3/5, y-intercept's 331. Not too terrible.